Oh, cool. Um, yep. So back to working on my zero to handmade hero, where we're going to learn how to create a game engine. No game, maybe a tiny little one, but more just learning how game engines work. So yeah, come along for the ride. What were we doing last time? We were working on our engine abstraction, kind of in my free time. I did go over a few things because there were a few things I wanted to check over and just tidy up. So it might look a little different from the last episode, but not too much. I'll kind of point out what I've changed when I go over it. Um, so yeah, let's begin. So the way we're doing this, so the way we actually previously did it was we had this game engine structure and a platform API structure, and we passed the pointer to both into this engine init. But I'm not going to do that anymore. What I'm going to do is game engine now. Let me show you. It doesn't hold a pointer to the platform API, it just holds the actual platform API. So what it means is I can just straight call my bootstrap my function pointers directly and just say, so our game engine platform API create window function pointer is going to be the win32 create window, and so on. So yeah, we're going to continue implementing some of these engine functions. So engine init, engine destroy, and engine reset. Not really sure if we need an engine reset. I kind of just in my head, all I'm going to do is just call engine destroy and then engine init. I don't know if that's how engines do it. That's just kind of what I want to do. One thing I've kind of realized as I'm adding some to-dos is I think of them, but not checking them off quick enough. So kind of building up that technical debt. So I guess what I'll do is I'll just kind of cross off some as we kind of go along as well. So a bit of jumping all over the place. I apologise. But yeah, we'll continue. So where should we start? There's to do. So what did I say? Right. So yeah. So here. So firstly, let's take show window out. So show window is a function from Win32. It shouldn't be in our main. It should be in the platform layer. So let's deal with that. No, Win32 platform. So I wonder if we just straight show it. I guess for now we can straight show it when we create the window. Or we could just say we'll do it like this for now. Oh. So int win32 show did I even give it a no, we don't. Do we need anything? So the moment show window takes in the handle to the window. So I guess it wants to take in an actual platform window, right? So that's taking a platform window pointer. And in the platform window, we will have a handle to the window that we need. Right, so we have window. What is it? Sorry, what is the wind? Right, I remember now. So we have our handle, which is going to be in the window, right? I don't want it to do anything just yet. Win32 show window. So we have our window handle, and then we just call show window. And as you can see, the show window function here, its second argument actually does return a bool, which is an int, so we could return that. Right, so we show window, and then I'll show window, so it takes a handle to window to show, and takes a n command show argument, and that controls how the window is to be shown. Okay, we'll just SW show it then. Okay, so we have our, oh, wait, what have I just done? Just gone down a page, yep. Okay, so we get our handle, we show the window, and then we are going to return call it success. Does that make sense? So return if the window has if the window was previously visible, the return value is non-zero. If the window was previously hidden, it's just not like a success, I suppose. Okay, we'll just do that for now. So we have a function. Okay. So where do we call this? So at the moment, I guess we could just call it in where we create the window. But maybe it's the engine who would call, maybe we need an API to show the window. We'll come back to that problem, and what we'll do is just add it in here. So we can do win32 show window, because we filled out this struct, right, for our window, so it has the handle to the window. Wait, what does it need? It's a pointer to window. So platform window is already, sorry, platform window is already a pointer. So let's just comment this out. One thing I did off stream actually is create a batch file to compile, so I'll show that. So all it does is it compiles two versions, one with a release flag and one with a debug flag set, and the executables names are changed. So one's engine debug .exe and the other's engine.exe. The reason I did this is because I was trying to debug I'll show you what I was trying to debug. But anyway, I've added this assert here, which this is not great. We should add like a logger, but all this does is if you just want to add the assert, if this is false, then we're going to write to a sorry, if the case is true, then we're going to write to a null pointer and just crash the program. So yeah, it's not great. It's not going to tell you where it's crashed or anything. It's just going to crash if an assert's wrong. Because what I was looking at, I don't know if you remember when we were starting the window, but it was only giving like a one letter banner. Let me show you what it is now. So if I compile, so it's compiled twice, so a bit annoying, but and then if I run my engine debug.exe, as you can see, we have 0 to Handmade Hero up in the top banner of the window. And what was previously happening is I just forgot that I wasn't using the default window proc wide. I was using the default window proc ASCII version. And so, like, if I run this again, so if I now compile, see, it compiles absolutely fine, and then if I run it again, you see, it just says the first letter, so it's kind of truncating the name. So that took me a while to debug. Well, I guess that's the Windows API. It's very confusing. Just gonna try and remember. I've got to always stick to the wide versions for now. That's what I want to do. Okay, so let's test now. So we did come out. So let's double check that again. So we compile, and then we run it. 0 to Handmade Hero at the top, Windows phone. So we'll show Windows now, part of the platform there. Cool. So that's out of main. So we just want to try clean up main. That's what this to do is here. So I add some checks, right? So what would happen? Oh, I guess that now is part of okay, so I do have a check. So basically, if create window comes back, so if our handle comes back 0, which means that an error has occurred, we just return null. So at the moment, it's not passing on anything else, so that's fine for now. Let me close this file. Okay, so for now, we'll delete that. Right, so now we have this while loop here. And I don't like it because we're directly here calling the pump message. The pump message ourselves. You know, we're directly accessing game engines functions. But what I kind of want to do is just have like a while game engine. Dot is running. So, something like this. So if we have a look, let me just close this. If we have a look in engine, we have this integer is running, and so what we can do is we can call engine destroy, I guess, if well, let's have a think about this. Well, I guess we want to update I guess in here we want like game engine dot Well, I guess the output from pump message, right? Pump message is an integer, so this returns 0 when we want to quit. So basically, win32 pump message will basically tell our engine to quit, right? So we in engine we basically also want another function something like engine, let's call it update frame. Oh yeah, so this is our engine implementation. It's mad messy at the moment, but let's run through it again. We call the Win platform layer to give us some virtual memory space, and then we create arenas in this memory space, and then our window is created in one of these. We push our arena, we push our window to one of our arenas. So engine platform create window, yeah. So on the permanent arena. But what I don't want to have to do, so I have the static engine pointer up here, what I was trying to do with them, and in fact let's just implement that now, is just so the static is going to keep these pointers to this translation unit, right? So anything basically outside this file is not going to be able to use this kind of global pointer, but it's global to this space, this translation unit, right? So this file. So what I can kind of get around by doing stuff like that is, I guess the way I normally look at it is like is kind of private in object-oriented languages, right? Not sure if that's a good way of looking at it, do not quote me. Like I said, this is a learning stream for me, but that's kind of how I look at it. But what we can do is, because the way it kind of gets messy when you have all these like structs within structs, and they're pointers and contain pointers, and you have a lot of the dereferences and dots, and I don't really like the way that looks. So what I'm going to do is do something like this, where I say the G engine pointer, I now want that to point to this engine that I'm passing in, and the G platform API pointer, I want that to point to engine dot platform API struct, right? And the reason is for that, sorry, it's because that is a pointer, so I have to dereference it, right? No? Oh, because it needs to be the memory address of it. I thought this would work. So basically in my head I wanted to because there needs to be a pointer, right? So engine, the platform API, like I said earlier, now actually holds the actual API function pointers, because it actually owns it. right, it owns the memory. It's not like borrowing it. It actually owns the API. Whereas like the window is kind of owned. It's kind of in heap memory, right? So we just kind of need a pointer to it. We don't actually need to own it. So is that not how you would do it? So I want to say my engine pointer, and I want to the platform API. Unless it's not called that. It is called that. Oh wait. Maybe it has to be here. Ah, I got you. Okay. So it's gets. Sorry. So the platform API is the engine dereference platform API, and then we get the address of that. Okay. So the reason I'm doing this is so now I can change like destroy engine, don't have to do that, and engine reset, don't have to do that, because they can just access the engine. Once I've initialized it in engine init, they can just access it via the global pointer. Right. So like the way this will kind of now simplify things is now I can change this can now become G platform API like this. So we call out our engine memory. So I think one thing we need to probably watch out for is kind of juggling each one. So I want to be using G engine engine memory, and does that just contain a memory chunk? So I can just probably just can I not just like use this and let's just see if we can pause so we haven't broken anything. Okay. So I know I'm arbitrarily picking just 2 gigabytes. There's not really any rhyme or reason for it at the moment. So let's just do something like this for now, right? Where we just define a max engine memory and we'll just write this into here. I think best practice would be to be able to pass it in from main, and so we can start the engine with different memory requirements, and or have something that checks the system memories. And but anyway, starting with 2 gigabytes of virtual memory space. I'm pretty sure virtual we use virtual alloc, I think, from the Win32, and I'm pretty sure that's not going to page all the memory. So it's not going to page directly 2 gigabytes in. It's going to set up like 2 gigabytes of virtual space for us to be able to use, and then when we write to it, it'll start paging in the memory. Whereas if we just were to malloc it, I'm pretty sure it would just give us 2 gigabytes of heat space and use that up in the RAM, and maybe we don't want to do that. So now we're initializing our arenas that are in our engine. So this is platform API where now this can just be changed to G platform API. It's now a pointer. So we should dereference it first. Now we can create our window. We pass in our arena. But I guess what I can probably do is, instead of having all these, I could do something like I can have an arena. I can just set up some pointers to arenas maybe, and say like pointer arena equal arena perm, and then we have engine and then okay, now this is also a bit annoying, right? So we've initialized our memory. We've called the platform API to initialize some memory space first to create our arenas in. So we need to divvy that up to our arenas, right? I think it's just a bit weird to do it like this. I'm gonna have to figure this out another time, because I don't want to sit here ironing for this whole time. But at the moment, it's just weird that it's like, right, I got called to the platform API. We're gonna ask for our max engine memory amount of heap space, and then like the first half of that memory space is going to be for our arena perm, and the second half of that arena space is going to be for our assets, and that's how we've divvied that up at the moment. Yeah, kind of strange. I'm gonna have to do some research on it, if that's how other engines do it, other people do it, but because the other way would be to have this kind of alloc in the arena itself. So when I call arena init, then I call out to virtual alloc, but then our engine, our arena, is then not Windows. It is not platform independent, right? It's dependent on Windows. So not ideal. Anyway, sorry, I got a bit sidetracked by trying to make that a bit. A bit more a bit cleaner looking. So let me use that again. So we're going to update our frame. So the reason we added that function, right, is to say void arena update frame, and it doesn't need to pass anything because it can access the global so basically we want to call this every frame, and basically what it wants to do is this is going to pump the message, right? So at the moment we have our pump messages being called in this while loop, right? Whereas realistically in here we want to say engine update frame, right? And we call the update frame function in this while loop. Now engine update frame will do some of our rendering, and then basically what it wants to do is if it gets a shutdown message, then it quits, right? So we're going to go here, we're going to say G engine and that's because it's in the platform API. Whoopsie. G platform API pump messages. Now, why don't you like this? Yep, because it's not platform, it's platform API pump messages, right? And if we go back to pump messages returns a 1, right? And then a 0 if it's quit. So what we can actually do is every frame we could say G engine dot is running, right? Is that's now equal to a pump message. So if it's dealing with messages and it hasn't received a quit message, then it's going to be 1, right? For is running, else it's going to be 0, and then we're going to shut down. Okay, engine update frames. A game engine is running, so we're kind of just taking this layer now back into. So now it gets stuck in updating frame. Obviously, this is going to just hammer it every CPU cycle. There's no waiting. But that's okay. We just try and move everything out of main as we possibly can, I guess. And then, right, oh god, if I can spell, engine, what did I call it? Destroy. I really just, you know what, I said I'd learn a bit, I've learned the bare basics of it. I used to learn how to split the screen basically in 2. So messages, engine destroy. So basically we're going to be stuck in this while loop, just hammering this update frame, then game engine is running, we'll get set to false, break out, and we'll destroy the engine. So this is it. This is all our main's going to be probably. But first we're going to implement that function. Right, let's see what I've forgotten to do. Engine update frame. Engine destroy basically because it's like can't find the implementation, so let's just do that. Engine destroy. So I guess what does it mean to kind of destroy an engine? We're just gonna cleanly kind of quit, I guess. Let me just check something. So I guess we want to But first we want to close the window, right? So we want to say G platform. Win32. We haven't actually added a we're destroying memory. I guess that's what we're going to be doing. Okay, so basically, Win32 destroy memory. So we're going to call that on. Okay, so we want G. Engine memory. It's G engine. Right, and then we want to, so we want to pass in the pointer to the memory to destroy it. So this is a pointer to the memory. Okay. So just straight destroy that memory. And the reason it's explaining is, once again, I've kind of messed it up by saying that it's not a pointer. Jesus Christ. And that's because the platform API, it doesn't, we're not pointing to this platform independent, right? So we just want to pass in the destroy. So we destroy our memory. Cool. But I guess what we want to do is probably destroy our arenas too. So when I have my pointer to my arenas, like so. So we want to have our, oh god, sorry, I should give it some. Okay, so we want to destroy our arenas. So how do we do that again? So we have a arena. Wait, do we not have an arena destroy? What does arena reset do? I guess it doesn't really matter. We're just kind of throwing it away. Yeah, like I could call the arena offset, but it doesn't necessarily matter. I guess for now we'll just. I don't want to delete the pointers, right? That's not what I wanted to do. I didn't want to do the points right, sorry, I wanted to... do something like this, right? Right, actually just set the... I just zero the structs, right? And be like, oh, well, that's me just saying it's deleted. So engine... Right, so let's go for it. So engine init. Wait, that was strange, wasn't it? That was odd. Okay, so what I'm gonna do is I should just start, right? Start the debugger, and I guess we can have a look at or not, I suppose. Right, so let's start in engine init. Let's do that. Yeah. So let's start the debugger. Is it not even reach there? I'm not sure the breakpoint's not working. Okay, what I could do is I can add my assert here, and I can say assert that oh, that's wrong. Because do I not set it? Does this instantly close? Am I just being an idiot? Yeah, I'm being an idiot. I didn't set it. So the last thing we want to do is have engine dot is running equal to 1. And now, wait, it will stay up. Has a lot of time to get up. So actually it's using 2 gigabytes of memory at the moment. I don't think it would, but it says it is as it is. Okay. So let's do void engine reset, right? And what I want to do here is just call so engine init takes in an engine, but I could restart the engine. So this engine should still So destroy will destroy the memory though, but that's fine because we're going to recall the memory here. So I should just be able to do that. And let's just test it. It kind of makes no sense to call that because, right, cause like, you can call it after initialized, but basically like, we don't want to actually do anything, right? If G engine then if it doesn't equal 0, then we can do that. Otherwise, I don't really know what would happen if it did. And then what we want to do is compile, Jesus, compile that. Ooh, I didn't close the window, that's why. Okay, so when I click reset, it has destroyed the memory to the old window, but not actually destroyed the window. Okay, well that's a fun problem to handle. Ooh, and they both have the same window handle because then I closed one. Okay, well that's a cool problem to solve, but for next time. So I think we're going on for just long enough, but anyway, we're kind of cleaned up our main function, have our engine there kind of sorted, we can kind of think about fixing that problem, and then talk about rendering probably next. So that's where I really want to learn. I know basically nothing. I've used OpenGL in the past for very getting a triangle, but we're going to do it properly. So in previous times, what I've done when using OpenGL is I've used glfw for the Windows stuff, and loaded in the function pointers. I think GLAD is it called, that loads the OpenGL function pointers, but we're going to do all that ourselves just so we know how it works. Cool. Well, cheers guys.